Alright guys, we're going to be looking at some geometric series, and we've got our formula here for you. You guys should be quite familiar with this by now. This Sn formula, sum formula. Now I've got two versions of it. You can memorize one or the other. We've got the a r to the power of n minus 1 over r minus 1. But if I swap these around and make it 1 minus r, this must also be swapped, so it's 1 minus r to the power of n. Now you guys know that Sn means the sum of the n terms. A is the first term and r is the common ratio, don't you? So make sure you know this very well, because what we're going to do now is you apply those and do some more calculations. Question 1 says the third term of a geometric sequence. Is 12, and the sixth term is 96. So you can see that they give us what the third term is and they give us what the sixth term is. That's what we're going to be using to calculate some values. Now first of all, they want us to find the common ratio, don't they? So what we're going to be doing is utilize the information that's already given to us. So we know that our Tn formula, the nth term formula, is going to be arn minus 1. I'm going to use that because they tell us what the third term is and what the sixth term is. So we have to use the nth term formula. So we're going to do that. We're going to start with the first information. Third term is 12. So let's put that in. The T3, if I replace the n with 3, the power will be 3, and that's going to be equal to 12 as they tell us in the question. Now let's use the next bit of information. I'm just going to simplify this, of course. 3 minus 1 is 2, so ar squared equals to 12. Let's just keep it like that. We can't do anything further now. So that will be our equation 1. Now let's put in the next bit of information. The sixth term is 96, isn't it? So I replace the n with 6, and you can see that's equal to 96 as they tell us. So 6 minus 1 is 5, so ar5 equals to 96. The power is 5. And again, we can't do anything further now, so I'll just leave that as equation 2. So we've got our equation 1, we've got our equation 2. We want to find the common ratio, which means we'll have to solve it simultaneously, won't we? Now what I'm going to do is divide. I'm going to divide the second equation by the first equation, and that's because if I can divide it, the a's in the front, the coefficients of a can just cancel out, won't they? And I chose the second one divided by first one because the numbers in the second one look a bit more greater, so you do the bigger numbers divided by the smaller numbers. So like this. So you can see the AR5 and equals to 96 goes on the numerator, and you can see AR squared equals to 12 goes in the denominator. And you can see, as I've told you, the A's actually cancel out, which is good because we just want to solve for R, the common ratio, don't we? So you can see that the A's cancel out. R to the power of 5 divided by R to the power of 2. We subtract the indices when we're dividing, don't we? So 5 minus 2 is 3, so we've got r to the power of 3 on the left-hand side. And 96 divided by 12 is just 8, guys. So guys, what's r? What cubed is 8? Must be 2. So the common ratio is just 2, guys. We've found the common ratio simply using some simultaneous equations. Now, I'm going to leave that there. So these were our two equations that we've got, and we've figured out that r, the common ratio, is 2. Now what we want to do is find the first term. Now guys, we were doing some simultaneous equations, weren't we? So we found one pronumeral, the r. So to find the other pronumeral, the a, which is the first term, just sub it into any of the first two equations, guys. Just sub it into any one of these and you should get the same answer. I'm just going to sub it into the first equation. So substitute r equals to 2 into the first equation, so r will be replaced by 2. So we have a times 2 squared equals to 12. Now 2 squared is 4. To get a, just divide both sides by 4, and a will just be 3. 12 divided by 4 is 3, isn't it? So we've got the first term. That was quite easy, wasn't it? Just some substitution. Now, we've got the a equals to 3. I'll just leave it here for a while. In part C, it's asking us to find the sum of the first 10 terms. So, now we have to use our sum formula. You know this one, right? I'm going to use this version of it. And we know what the first term is, we know what the common ratio is, and we know that n is going to be 10 because we want the sum of the first 10 terms. Put everything in. So, a is 3 as we've calculated in part B, r is 2 as we calculated in part A, and then as I said, guys, the n will be 10. Just plug all that in your calculator, guys. You should get some value. This will be the sum of the first 10 terms in this particular geometric series.